Solutionology is about being unyielding with perseverance to get to the solution.
To not give up and to constantly drive for better. So even when we deliver 100%, I want to deliver 110 next time.
And for me, the constraints of that project are the most important because that's what drives us to a solution. It's all about painting a picture and getting all the details in.
How do we develop a tool that helps share our journey, educate others, and bring more light to the realities of additive manufacturing? The Solutionology podcast. Well, welcome. We're really pumped today because we've got these beautiful ultra white parts on the table here, and we're sharing something that we've been waiting for years.
Ultra white? What the heck are you talking about?
Yes.
What is ultra white?
So, ultra white is a term that we made up. It's obviously two words put together, and it's a term that we made up to define HP's new multi-jet fusion technology. And the way that we see it is ultra white is extraordinarily bright. It's a cool white. They're parts that can be sanitized and sealed, and they stay white through the through their lifespan. And they can even create ultra bright colors.
Welcome to Ultra White. So we were selected as the only US beta user from HP on this ultra white parts and the HP system that we have installed in our facility. We're the only user in the US, the only beta user. This beta has been launched at FormNext, and we're publicly releasing our partnership with HP and bringing in beta testing the device. And we were selected partly because of our commitment to quality and serving the medical industry and being a known source for quality goods for those clients.
Yeah, quality and consistency. That's one of the things that we find is one of the biggest questions about additive manufacturing, especially in medical devices. You're contemplating going from injection molding, which has always been the traditional go-to resource, and thinking about additive manufacturing. The question is always, can you make parts that's consistent? If I need thousands of parts, can you do that for me? And we found that you can. We do produce thousands of medical part devices and complete assemblies that work just as well, in some cases, if not better, than they were injection molded. So we've been doing that, and our relationship with HP from a technical standpoint has been really great, and the recognition of our technical competence when it comes to manufacturing process control has been part of that selection. We've been putting this machine through its paces. We're testing the capabilities of the machine to understand where the boundary limits are. They call the machine the model number is the 5420W, but it's essentially the same fundamental technology as their core multi-jet fusion, where the parts come out gray, but in this case, the parts come out white. And this is particularly interesting to us because we do so much work in the medical device, healthcare and medical device space, where there are a lot of requirements for having white parts. Historically, parts have been white. They've been accepted that way. They look cleaner, sharper. You can tell when they've been contaminated. So there's just a legacy of having white parts in operating in surgical applications. So for us, we've been pushing for this for some time, and we've been delighted to have the first white multi-jet fusion machine in North America, and we've been putting it through its paces over the last couple of weeks. We've run well over 1,000 parts, if not several thousand, in that amount of time, understanding the production processes, the dimensional attributes, and the surface quality.
So the white parts give us a big advantage over having the standard gray MJF. We're able to process white in a lot of different ways. So rather than being stuck with producing a mostly black part, especially after smoothing, which is really important to us. The smooth surface finish is a critical aspect of all the parts that we produce. With gray MJF, we're really limited to black once those parts are smoothed. Now with the ultra white nylon, we're able to transform these white parts into any color without adding additional surface thickness. So we can maintain the high accuracy and dimensional accuracy of the parts, but still have great color contrast like we see here with this red part.
So we run a lot of different technologies, including SLS, selective laser sintering. And of course, SLS technology typically produces white parts. They're a little bit of an off-white, more warm than cool. And we actually invested in that technology primarily for medical device. And that's got some great applications for us still as we diversify our material portfolio. But the thing that the MJF technology offers over SLS is it provides an incredibly high-resolution surface finish. So as we're thinking about applying textures, having a really smooth surface, MJF has always done such a great job on the gray for us. So we've been even more happy with the surface quality of the white parts. That they seem to be extraordinarily detailed. Maybe there isn't much of a difference from the standard gray, but it sure comes across sharper.
So as we're looking at the high resolution details that we have on the ultra white parts, on all the parts we have on the table in this corner here, we've texturized these parts, and our process of texturizing these parts allows us to create unique features and make parts that are unique.
Medical device applications, in our experience anyways, typically require parts to be smooth. And we do have textured parts here. So we also see a significant market need for these types of parts in consumer automotive types of applications. So these are textured, and what we've been developing, not exclusive to the ultra white, but what we've been developing is a texturizing digital workflow that allows us to apply virtually any texture we want to any of the parts. So we have hundreds of different types of textures that we can apply, and it's not very difficult for us to develop a texture from scratch and then apply it to parts digitally. So there's not a lot of work involved. We've been playing a lot with the white parts, with the ultra white parts with the texture, and have just found that they're remarkably sharp. And then it's kind of a neat little happy accident. But in this particular part, it's an automotive part, and we included the snap tabs built right into the part. Rather than having those separate components, they're designed right into the part. And the level of detail and strength in those tabs is really, really remarkable. And I'm not sure that that's something that, there's really not many other technologies that can produce those types of features with such detail and strength.
Being able to apply the texture to the surface of the part, it definitely allows us to improve the aesthetics of the part, but there's also the opportunity to use texturizing as ergonomics, so that if we're making a medical device, we're able to apply textures in key areas to assist with the functionality of those parts during use. And that same ergonomic sort of texture creation can go beyond the healthcare industry. So we can get really creative with making products more intuitive without adding the additional costs that you would have with other processes. So thinking about the medical industry, what sort of benefits do we have outside of it being a white part?
Yeah, so HP's been working on the biocompatibility certifications. These are certified as being biocompatible. They're working on the sterilization validation testing. The early results indicate that these perform well through multiple sterilization steps, both using chemical, heat, and radiation. So all indications are that this is a great solution for medical device from a biocompatibility and sterilization. And we've experienced that, of course, with the standard MJF, and there's no reason to believe that this won't perform just as well. At this point, it's just a matter of the formality of getting the documentation through the system. The other attribute that's really positive about these parts is with traditional SLS, there's a tendency for those parts, they come out white, and there's a tendency for them to yellow over time, to degrade either from UV or thermal or just oxidation. And what's interesting about these parts is the surface treatment out of the machine stabilizes the parts to prevent that. And HP is also doing testing on that, including UV stability analysis. And from what they've been sharing with us, that the parts perform very well. And from what we understand about the surface treatment, there's no reason to believe that they won't outperform some of the other white technologies that are on the market. And of course, they're nylon 12, which is being used in so many other applications and manufacturing processes that it's a known commodity at this point.
Yeah, so color uniformity coming out of the machine is just as critical as the longevity of that color as it's exposed to its end-use situation. So we look forward to the testing results that we get on this and doing testing ourselves to see how that we experience that color in real time as well.
Yeah, and that's an area where we have done some visual analysis, and the parts have come out incredibly consistent from build to build for the white color stability.
So all these parts that we have on the table, they're finished using our vapor smoothing technologies that we have in-house. The part as it comes out of the machine is going to have a slightly rough surface, probably like 120 grit sandpaper. And the vapor smoothing allows us to seal that surface and allows it to be cleaned and sanitized. And that's really important for automotive, medical. We can't have porosity in the surface, and that sealed surface is critical. It gives it a smooth surface on the texture.
Yeah, and it gives it more of a it's like a satin, maybe a satin finish. It's not quite semi-gloss, but a satin finish where the natural parts coming out of the machine are undoubtedly matte. And so there's inherently, just from a sheen standpoint, there's inherently more resistance to contamination from dirt, just having a higher gloss sheen, the sealed type of surface. And you mentioned early on, not all parts need to be white. So we've got a sample part here that started its life, of course, as a white part, and then we dyed it red. We colored it red. So we've also been doing quite a bit of testing on coloring these parts. We've found that it takes color extraordinarily well. So we've probably done almost every color in all of the primary and even some of the secondary colors, and we're really impressed with the colors. And those are things that we haven't been able to achieve on standard MJF because the parts come out gray, so we just can't get that color brilliance that we're able to achieve with these white parts, with the ultra white parts.
We've been really excited to work with HP and be a support partner with them and bringing this ultra white out to the industry, be the first in the U.S. to do this. It's been a real fun time.
It is. It has been really productive, and HP is a valued partner for us. Most of our business is volume manufacturing, so producing parts in thousands, tens of thousands, even up to upwards of 100,000 parts. And we have a lot of technologies that we work with, but the HP technology, the multi-jet fusion, is really the only technology that scales from the way we operate, scales in volume to those volume levels of tens of thousands of parts. And the standard multi-jet fusion has done that tremendously well. And being able to leverage now the 5420 white machines will be a significant advantage in serving the marketplace. There's no doubt that there's there's a need for this. So it's really great to see that HP has come to the table and provided this solution.
So part of our launch of ultra-white parts with HP is that our parts are sitting in Germany at FormNext, and you can see our parts there if you happen to be visiting FormNext.
So we've got several of our parts on display at FormNext, and I think we sent all automotive. Yeah, so we sent textured samples that are primarily for the automotive industry. Yeah, if you're there, check them out for sure.
You'll see the this trim piece for automotive. This will be at HP's booth in FormNext. So this one will definitely be here. I don't know if we have any others, but this one's definitely there.
And it's red. So that one we colored red, which is actually my favorite. It's that steering trim with this texture, with a geometric texture, which I kind of wish we hadn't sent it because it's such a sharp-looking part.
Be great to see it in person.
I guess we'll just have to make more.
Yeah.
So if you find yourself with a need for ultra-white, contact us because we're running the machine, we're running production, we're continuing to evaluate the technology, but on a parallel path, we're also starting to run some production. So if this is a technology you find yourself desiring for your applications, we'd be happy to serve you. And I expect that we'll have the technology fully onboarded here within, probably by the end of this week, by the end of the week of FormNext, and we'll probably have been delivering some of our first production orders off of it. So yeah, please contact us if you're interested in experiencing the ultra white.